welcome to this week's episode of Automated. I, of course, am your host, Stefan Soxmacher, co-founder and CEO of Polymath Robotics. Ilia is rapidly trying to decrease the gains or increase the gains because audio technician is mystery so that I'm less loud. This is our weekly podcast where we talk about robots, how to build them, some silly stuff in them. Sitting across from me is a man who's wearing an outfit similar to mine, but with the important exception that he's not wearing a Polymath Robotics t-shirt, which I think means he's just generally less good of a person. Sir, who are you in your nondescript black shirt?
Yeah, I ran out of Polymath swag. I think that's a fundamental flaw.
Yeah, I'm writing a letter to the editor. The editor of what I can't say. This again is our podcast Automated. We try to do these every week. We do these in two sections. The first of which we kind of spitball a robot into existence. And the second of which we talk about some sort of topic in robotics. Ilia, what are we going to talk about?
We're going to talk about overkill and underkill in robotics.
Overkill in robotics? That doesn't sound like a thing that would ever happen.
No, definitely not.
I also want to give a special shout out. We were meeting with a potential partner earlier today who's going to have some members of his team look at our stack. And we heard back from this partner like immediately after he pinged his team saying that team member listens to this podcast. So
hello.
Hey, how's it going? Hope you really, really love our product and tell everyone you work with that they should do everything with Polymath.
That's the goal.
That would be helpful. I kind of thought like, growing up, I always listened to Car Talk with my dad. And I feel like nobody who listened to Car Talk really did any work on their cars. So that's kind of the like, oh, wow, an actual mechanic is listening to our show. That's kind of neat.
Exactly. One of my ex-colleagues, Simon, I'll just say the first name, loves to listen and then critique any technical explanation I make about like, well, actually.
Last time we caught up with him, I think he had a couple of things he wanted to chew us out about for maybe like 4 episodes prior, which of course I had forgotten because a butterfly flew by.
Difference of structured light versus time of flight.
Yeah, it's an important difference. So with that being said, let's get going. So we're going to play our game here. And in our game, I'm going to draw a technology card and Ilia is going to draw a business card. This kind of simulates starting a robotics company. So Ilia, what sort of business are we going to be in?
All right. Top of the stack. Bar, we did. Let's pull another one. Public pool, we did.
And I should say that we had been missing our tech cards for a while. And I had accused many a person on the team of stealing them. And then it turned out that they were just under one of our sound canceling discs on the table that no one had looked under. So I was bullied earlier heavily.
Classic moment, I'm sure. Movie set.
What?
Movie set.
Movie set.
Yeah, like the set of a movie. Or let's broaden it to movie production.
I just drew a perfect card for this.
All right.
And this is like not fake. I mean, not that these card drawings are ever fake. This one's very much not fake. Humanoid robots. Westworld.
Oh, not only Westworld. Who was it? Sony made a robot to do some of Spider-Man's stunts.
Really?
You can look this up. There is a humanoid robot that does some stunts for Spider-Man.
I know there's a humanoid robot that the Disney Imagineers put together because there's a live action Spider-Man show.
Yeah.
Where the Spider-Man actors like on stage and he climbs up the building. Then a veil goes in front of him and then a robot that looks like him web slings across.
Yeah. It might be the same project or a similar one, but yeah. And they've been used in movies as well. So I
think Westworld, like something like Westworld or something where, I never actually watched Westworld, but something like where
it's not bad.
Where you could have stunts that like are actually pretty like a single motion capture where the character blows up. So I want a humanoid that looks like a humanoid through a movie lens, which is actually very forgiving, right? They don't need to walk perfectly.
Yeah.
They don't need, anything in the, what's that gap?
Uncanny Valley.
Yeah, anything in the Uncanny Valley you can fix in post. You know? So we don't need to solve like lifelike skin. We don't have to solve any of that. But I want, a scene in an action movie where someone blows up or someone gets shot to be very gory and like one big shot and not made in post.
And entirely practical effects.
Yeah, practical effects. Like I want a practical effect where like Terminator walks out, pulls out the minigun, shoots up a big crowd, and like you're seeing some shit. Like you're gonna have nightmares that night because of how real it looks.
Yeah, I think it's good you brought up the Uncanny Valley because the real painful part about this would probably be the face and facial expressions. Mm-hmm. Humans are super dialed in to facial expressions. So as long as you don't have to mess with the face much, all the shots are from far enough away they don't really see the face very clearly.
Yeah.
You'll be fine.
Yep.
And you can make a walking, sort of stilted, but not quite, walking humanoid for reasonable amounts of money. Like less than you'd pay an actor, for example, for sure.
I mean, like, I think like disposable humanoids.
Yeah. So, I mean, again, look at the agility machine, which we don't have insider info on costs or anything like that, but making guesses here, 50 to 100K in any sort of reasonable volume.
I mean, when you think about like the big famous shot in Apocalypse Now, where as a fun fact for anyone who doesn't know, that movie took a long time to film, blah, blah, blah. There's a bunch of like bombing scenes where where the equipment in it was actually from the Philippine military. And in between takes, they'd go and like bomb rebels and, commit war crimes and stuff. But what's a little war crime between friends?
Oh, no.
But like literally the same munitions being used to like blow up tree lines for effects were then being, dropped on people.
Oh, boy.
So do stuff like that, but drop them on humanoid robots.
Well, it'd be interesting. The humanoid robot, like a practical consideration you might have is you're going to have real batteries and real stuff in there that you don't really want to just burn on set. Like, it's pretty noxious.
I mean,
like nobody wants a lithium fire going in their backyard.
But like, I mean, if in the good old days where you could build a whole like ancient Egypt and then bury it in the desert, like you can sort out the lithium fires in post.
In the good old days, they didn't have robots.
I mean, like, how big of a battery do you need? If you need this thing to only run, maybe like let's call it has to be. Having never acted, I assume it's pretty easy. So
classic engineer statements.
So call it like 5 takes at a 5-minute scene, 25 minutes of runtime. Call it an hour of battery.
Yeah, you clearly haven't been on a set.
A line that I heard from Justin Kahn from pre-Twitch when they tried to make it Justin TV, which was a live streaming reality show about his life, was that for every minute of TV tends to take an hour of filming.
Yes.
So maybe 5 hours of battery, but like you have multiple takes, so you could recharge the battery.
So yeah, once you're getting to 5 hours of battery, you're beyond the battery life of any humanoid that exists today for any usable amount of time.
Okay, but what if you had like 30 minutes of battery and you had a hot swappable battery?
Hot swappable battery or something like that.
An intern could do that.
Yeah. But I mean, even a small, in quotation marks, small battery pack would still be undesirable to burn.
Yeah.
Maybe make these things hydrogen powered. It's got to inject a little bit of fun here. Right? Just have a little hydrogen tank on the back. A little
another take of humanoids in film or in movies could be a TV show that's primarily made with humanoids. And then fans can go visit and participate in episodes of the TV show that are written on the fly by LLMs.
There you go.
So like I watched The Office obsessively. And there was like a Dunder Mifflin experience where they're like setting up locations in different places. You could go to Scranton, go to the Dunder Mifflin office, buy a ticket, go in, and like Pam's at reception, treating you the way that Pam would treat you, regardless of whatever stupid stuff you said.
I feel again you'd fall into the uncanny valley though. As soon as you get close enough to these people to have to interact with them, the face is not quite right. The eyes don't work quite right. Like we're still far away from that.
Well, what would it actually take to make faces work like faces work?
Sci-fi technology for now. I don't think anybody's cracked that code. The reason I say that is because we can't even animate it well. And animation has no physical constraints on it. And we can't animate it to the point where it doesn't look bizarre.
But if you rebuild musculoskeletal systems, you could kind of, couldn't you? Wouldn't in some ways, like if the physics comes for free in real world?
In theory, yeah. But in practice, there's so many muscles in your face. I'm going to lie about the number, but like high hundreds of muscles in your face. Mm-hmm. So every expression you're doing, you need hundreds of actuators if you really wanted it accurate. Like if you really want to go for a biologically accurate build, you're looking at like a ludicrously complicated system.
So in other words, maybe there could be humanoids in movies if it's a far away shot.
Far away, yeah.
In which case,
and they get blown up just for a special effect.
Maybe you just use extras.
The blown up ones.
Yeah. Maybe not. So if we were to have these humanoid extras, I think the extra 3,000 It's the right name.
I think the company name should be "We Do Want to Take Your Jobs." If it's getting blown up.
Or it could be extra.
Extra. There you go.
Yeah.
Little paperboy hat.
With that being said, what are we talking about today, Ilia?
Yeah. So we were talking earlier about approaching robotics projects and
sensor and BOM allocation.
Oh, sensor and BOM. Yeah. So basically, how you want to build a machine and what in terms
bill of materials you want to have
in terms of bill of materials, what do you actually need on it? So if you're starting out a project and you kind of have a rough idea of what you want to do, like automated, I don't know, coal mining, for example, making up an example. You have some idea of understanding of, okay, the machines that are in this space tend to be this size. They tend to have a human driver. So probably vision you'll need feedback from the system. But what we've seen kind of two drastic ends of this approach. One is this, what I would call overkill, where it's just throw every single possible sensor you could imagine, 12 radar units, 30 cameras, 10 GPUs, and hope that given enough hardware, you can make the software work. Yeah, exactly. You just it's like the machine learning. Just throw data at it and it figures it out.
Data's the new oil.
Yeah, it'll work. And then the other extreme end of this is underkill, where the company will say, no, it has to fit
the BOM that I imagine I'll be able to sell this for in 3 years.
Exactly. It has to fit this theoretical bill of materials. And some very clever MBA has done a market study and has come back and told us that we can't sell this for more than $10,000.
Yep.
And so
the BOM needs to be $1,500, $2,500
to be profitable.
And maybe we're okay with it being $3,500 for now.
Exactly. So given an unspecified problem that's nobody ever solved before, solve it on a budget of $3,500 total, please.
So the overkill approach makes a lot of sense to the naive non-roboticists. Like in the earlier days of like robo-taxis and self-driving car, the argument's pretty straightforward. It's, hey, if we solve robo-taxis, we're going to make like $1 trillion a year. So like whether each car right now costs 20 grand or 200 grand or 20 million, who cares? Like, let's get it working and then let's cut all the rest of the fabric we don't need. But eventually these LiDARs will be cheap.
Yeah.
Eventually these GPUs will be, I don't know if you've heard of Moore's Law, but like compute gets drastically cheaper over time, which is why the GPU that costs $8,000 today will cost $80 next week.
That's why when we were at CS last year, we saw a plethora of solid state $5 LiDARs.
The spoiler is that if anything, these bill of materials budgets for these vehicles tend to stay flat regardless of how cheap the individual sensors.
Yeah, exactly. Yeah, my particular one that I like is stuffing desktop class GPUs into a machine, which again in research like makes sense.
Yeah,
right. But as soon as you transfer to a real vehicle, spending 400-500 watts of power to run a consumer grade GPU seems odd.
Are you saying it's not just about the budget, the dollar budget? There's also a power budget,
power, thermal, weight.
But I also want the thing to be electric powered.
Oh yeah, of course. That's right.
I think I remember seeing an article a couple years ago that the BOM on an electric robotaxi decreased its range by like 20%.
I'm not surprised at all. Like, yeah, it adds up, right? Every desktop class CPU on there is using 100 watts, and it's using 100 watts constantly as soon as the system is turned on.
But I guess like what's fundamentally wrong with like throwing too much sensors to it? Or throwing like an order of magnitude too many sensors at a problem.
It's a good idea in theory, but when we were talking about it, I kind of likened it to the tyranny of the rocket equation. So taking a quick digression here. If you're launching
digression on this show, never.
No, absolutely not.
This is a serious podcast for serious professionals.
I think we
need to tell their boss to buy lots of polymaths.
I think we should change the name to a series of digressions. But tyranny of the rocket equation is that if you want to launch anything to orbit, whatever you're launching needs fuel to get it there.
Yep.
But then you need fuel to move that fuel. Yep. But then you need fuel to move that fuel to move that fuel.
I think the solution's obvious. Massless fuel.
Yeah, exactly. Yeah. When you invent it, I think you'll stop hosting the show. Lots of people have tried. I've been excited about a few of the efforts, but it hasn't gotten there yet. So, you get this problem where every gram of payload you want to get into space needs an extra, I don't know, make up a number here, like 200 pounds of fuel.
My favorite like short on this is that for anything that you want to put in space, costs roughly that thing's weight in gold to get into space as a heuristic.
Yeah, and that's a cheap launch. That's like a SpaceX launch.
Yeah.
Before that, it would have cost 5 times its weight in gold. Yeah, so the same kind of thing happens in robotics where it's really great in theory to have all the sensors in the world and all the compute in the world, but you get this sort of tyranny, same problem. Every additional sensor you put up has additional failure points, additional wiring that could go wrong, additional heat and thermal characteristics, additional field of view problems and dust problems.
But can't
and
you
noise
just
problems.
turn them all on and sort it out?
Yeah, just machine learn it. Just machine learn it. I mean, one of the funny things we realized working on this is that actually a lot, for example, concrete example, a lot of GPS receivers or positioning receivers in general, GNSS receivers, are heavily affected by noise generated by LiDAR.
Yeah.
And we have seen a few public photos.
To the point where yesterday, Ilia interrupted a meeting we were having with a VC to point out that someone else had a LiDAR directly mounted on top of a GPS.
The GPS right
While
on
the
top.
VC was just mostly like, why are you talking about this? This is a weirdly bespoke point.
Well, I was trying to make a point that that's not a real program. They're getting garbage data out of this thing. But yeah, so the more sensors you stuff on there, the more problems you have with power, the more problems you have with thermals, the more problems you have with physically positioning all these things. And so you end up with this monstrosity that is very high support requirements.
Effort.
Yeah, very high effort. Yeah. Right? Very, very high effort.
Yeah, I mean, a question that I always got at Starsky was kind of infamously anti-LiDAR because the LiDARs that were available to us didn't work.
Yeah.
They didn't have relevant range at highway speed. And if you looked at them the wrong way, they fell apart and trucks shake a lot.
Certain LiDARs were hot glued into place as a normal matter of assembly at the time.
So I had to spend my whole life defending to VCs why we didn't use LiDAR. And they'd just be like, but if you threw a LiDAR on there, wouldn't the whole thing just be safer? Why not just throw more sensors on the vehicle? And I think what is hard for people to appreciate is that, robots are really hard, suck a whole lot for a whole bunch of reasons. They're already stupidly complex. And complexity means unreliability. Complexity means hard to make work. Now, if you double that complexity or triple that complexity, you might just never, we've had robots that suddenly stopped working because somebody plugged an extra LiDAR into the wrong switch and the LiDAR just started flooding the whole network. And the compute got exhausted from trying to keep up with a billion high data messages.
Yeah, exactly. It's again, going back in computer history, the first computers that were running on vacuum tubes, like the ENIAC kind of, somebody had done a calculation that to scale that to the level that they needed for space program, for example, they would be replacing one vacuum tube every minute. And when you replace a vacuum tube, you can't just hot swap the thing. You got to shut down the whole system. So there's this beyond a certain level where it becomes unmaintainable. Yeah. Now we're not quite at vacuum tubes today.
Yeah.
But robotics and robotic sensors
these days.
Less.
Yeah.
Not none, but less. Right. So when you're designing your own company or your own project in robotics, you got to think about what is a reasonable level to be at.
Yeah.
That's not overkill.
Because you're still going to be wrong.
You're still going to be, for sure.
Yeah.
And we've been wrong many times too.
You're still going to need one more sensor in this one field of view that you didn't care about before.
Or one sensor you paid a lot of money for ended up being functionally useless.
It's funny. I was at this talk last night about for startup founders, how to get to out of start getting good at founder-led sales. And the kind of Twitter celebrity, Chris Baki, who gave the talk, mentioned that the hot tools in B2B sales change every 6 months. But what a lot of companies do is the CEO reads a blog post that's 2 years old. That blog post says, here's the 5 tools you need. They go buy those 5 best-in-class, fanciest tools for $200,000. And then 3 months later, why doesn't the thing work? And similarly, I think another version of that is, I read that, this 76 beam LiDAR is really great. I read that this super RTK differential GPS is really great. I heard that this, that, and the other. Let's throw them all on there. Engineers figure it out.
Yeah.
And that's just not how the world works.
Yeah, exactly. And even okay, assume you solve the money problem of these things being horrendously expensive. Yeah. Then the argument I hear is, it's okay, we'll start here and we'll cut down sensors. There's 2 problems with that logic. One is you don't know which sensor to cut. Because unless you do a huge amount of work to figure out what is the cardinality of any particular sensor you're reading, so like how important is any particular sensor to the outcome of your localization solution, which is a non-trivial problem. It sounds easy, but it's fairly non-trivial.
Yeah.
You're not
in other words, just to simplify a little bit, which sensor you're actually relying on at any point in time to know where you are.
Under what conditions, in what situations, and what use cases. Like, it's a very high dimensional problem to solve. And so you don't know which one. And then B, even if you did know which one, you've built a code base to use those sensors. So now ripping them out is painful. And you probably built
that code base on a tight timeline with probably not a lot of modularity in it, which means removing that one sensor, suddenly your whole system doesn't work and you have to rebuild it. And there's mystery debugging.
Yeah, or the really bad case is actually it works most of the time and realistically. And then 5 or 10% of the time it fails mysteriously and you have no clue why. And that's
so given that we have a tight timeline.
So the opposite end of the spectrum.
Opposite end.
Underkill. Underkill is basically when the company says, we don't know exactly what we're going to build, but we've done an MBA study that this market can only support $5,000 per unit.
Yep.
To make a profit, we need a 50% margin. So your bill of materials or BOM cost is $2,500.
Yep.
That's all you get. Solve the problem with this. And I'm not going to allow you to put any extra dollar on there because we can't ship that as a product.
Yep.
The problem with that approach is that when you're in development, you're necessarily not building your most efficient code, right? You need time to optimize.
I only ever do everything perfectly. I don't understand. Every time I practice, it's 100%.
I mean, I've heard that zero code is the Zen state of perfect code. So I have to agree with you. There's no bugs. It's 100%. It's perfect.
Never written buggy code.
That's right. So you're really hobbling yourself when you're building something that's to the absolute limits of what you're trying to do. Even basic stuff like you need to run a data collection node on your system. So when I was at Amazon working on the Astro program, we had this problem where we had to end up being very clever on how we data collected because running the data collector and running the autonomy core at the same time would flatline the CPU. We'd exceed the thermal limits of the CPU.
So data collection basically had to be super manual.
Yeah, it had to be. We had to be very clever with a bunch of tricks of simulating pieces and simulating other parts. So we spend a lot of time and money and effort because we refuse to add more compute in the development phase.
Yep.
And I'm not talking 10x or 100x. I'm talking like
another cell phone.
2x. Right? So don't underkill either.
Yeah.
Because you're underkill will cost you a lot of time and effort and pain unless you know exactly what you're solving.
Yeah.
If you're a LiDAR manufacturer, like Astra that we use quite a bit, you're in the 7th rev of your product. Absolutely, you can specify to a T exactly what you need on the sensor.
Yep.
You should.
Yep.
But if you're doing a cutting edge new robotics project and you'd have a very fuzzy understanding of what you're trying to do, underkill is just as dangerous as overkill.
Yep. And I mean, I think what is hard about robotics in general, like going back to like how we've talked about consulting robotics before, it's really hard to know what is valuable and buildable in robotics. And then when you even know what might be both valuable and buildable, knowing just how hard it is to build and how maintainable it is once it's built, which means that if you mess up any of that, you suddenly need a lot more compute, or you suddenly need a lot more sensing range, or you suddenly need a lot more whatever. Like maybe the Astro's killer app requires a robot arm. That platform could just fundamentally not support because you'd need a whole lot of new things to have a robot arm added to that platform. And I think that's part of the big challenge with the productization of robots in general is that everything's so hard these days that the future is particularly unpredictable, which means you can't take a lot off the table.
Yeah. Yeah. And you also don't want to overinvest in like the latest sensor that will solve all your problems.
Yeah.
That generally doesn't exist.
One day there will be the sensor that tells us the current state of the world perfectly and what the state will be 5 minutes from now.
I'm just hearing people in my head saying, oh, it has to be cameras. That's how humans operate. Okay. Build me a human brain first, and then we'll talk.
How hard can it be?
Absolutely.
And with that, Ilia, what are we talking about next week?
We'll have to figure it out as we go along.
Depends on how many people listening to this reach out through ways of their bosses to tell them,
Actually, speaking of which, open suggestion line. reach out at hello@polymathrobotics.com with any topic you'd like to hear about.
Yep.
We'll read them all. We'll poke fun at you if it's particularly good.
Yep.
Yeah. Send out your suggestions. Come see us at CES. We'll see you next time.
We're going to be at CES. You can stop by. You can drive some robots and talk to us in person and make fun of how much better looking we are than we sound like we look.
Or worse.
Impossible. And with that, thanks so much.
See you next time.